What? Oh gosh.
Funny.
Okay, let's do what we gotta do. Have a game. Spent the whole morning making.
Oh.
Yep.
Oh, you're gonna reuse it, yeah.
Huh?
You're gonna reuse it.
Oh yeah, of course. Okay, so so you said we're gonna do all? Okay, I can set up all of them.
-25.
Oh yeah, can you at least like I think I got my limit.
Okay, so in problem 1a, you got y equals 6x minus x squared, y equal x. So we'll find the centroid of this region. So we have a parabola opening down, 1, 2, 3, 4, 5, 6. Ooh. And y equal x looks like this. Well, let's find the points of intersection first. So equating the y's, you get this. So 0 equals x squared minus 5x. So it's 0 and 5, yeah?
Yeah.
So x equals 0 and 5. Wait, so 0, 0 and 5, 5. 5, 5.
We can.
Why is it 5, 5?
Because y equal x.
Oh, yeah.
Am I not graphing this correctly? 5, 5. Ah! 0, 0,
Wait, that's not what my graph was.
5. So it's kind of look, here's the line. And here's Johnny.
Here's where that's 4. That's 4. You put the one at 4. Yeah. Good.
Okay, so neither the x nor the y coordinate came up.
No.
So the x coordinate of the centroid is equal to the double integral of x. Now, I think in this case, I rather integrate with respect to y first, because y will go from x to 6x minus x squared. And then I'm going to integrate with respect to x last, and then that just goes from 0 to 5. And then you got to divide that by the total area. Actually, you don't need a double integral to find the total area, but what the heck. dy goes from x to 6x minus x squared, and then dx will go from 0 to 5. Right, if we do double integrals. Because who knows, on the test it might just say write integrals that, I mean, you don't actually have to compute the centroid, you gotta just write these integrals here. Okay, so which integral do we want to do first? No, once I write this down, you guys can do it, right? No, but Jason said his didn't come out, so let's do it. So if you integrate, did everybody get the denominator then? We can save time.
Wait.
What did you get for the denominator? Wang?
I got. Oh, I like canceled it with stuff on the right side, but I got like 125 over 3.
Is that what you guys got?
I want 25 over 6.
I got my limits wrong.
Oh, yeah, because I'm.
Okay, we got 3 different answers. Part.
It's 125 over 6.
Remember what I told you? Okay, one more time. That's it. Your grade goes down 1. If you guys don't want to do work, you're gonna pay for it. What?
I watched video lessons though.
Oh yeah, congratulations. You're here in class. You don't need to watch the video lessons. Yeah, you miss the part I do when I'm sleeping.
Sometimes I'm just kind of.
Wait, how do you know when to do the x or the y? Because that's what I was.
Well, you can. Well, this problem you kind of have to do the y first because you're going from the bottom curve to the top curve, right?
Because the example we did in class, it was like y dy dx, but this one's x.
Oh,
It doesn't matter. You can do either. When you do a double integral, you can do either one first, right? It doesn't, or even triple integral.
So we did y dy dx. It's the same.
No, y dy dx is for the y coordinate of the centroid.
No, you're just talking about this part here.
Yeah.
This part.
Yeah.
Yeah, it doesn't matter which order you
Oh
do.
no.
You do it
The
in whatever
X line, whatever that's called.
X bar.
Yeah.
The X
bar.
coordinate of the centroid.
Oh, we're doing the x group. That's why I was confused.
The Y coordinate of the centroid, there would be a Y there.
Oh, so we have to sum both the.
What?
Yeah.
Oh, that makes sense. I thought you only do one of them, but that's what we did in class.
No, because we remember the one we did in class had symmetry. That's why.
Yeah, I thought that.
So then you already knew like what the X coordinate was, because it has to be on the line of symmetry, right? But the Y one we have to figure out. This one though, there's no symmetry, so we gotta actually figure it out. Both of them. Okay, so, okay, let's do the,
It's 120.
this is gonna be a long class.
No, it is 125/6. It's because I canceled it.
Okay, that saves some time. So let's say the denominator is 125/6. How do you compute the top one? Well, what's the integral of x with respect to y? xy from x to 6x minus x squared. Factor out the constant. Remember, x is a constant here, yeah? So you got 6x minus x squared minus x, and we're going to integrate now that with respect to x from 0 to 5, and it looks like we need to multiply this out. 6x minus x is 5x. 5x squared minus x cubed. This is all computation. So going up here, we got 5/3 x cubed minus 1/4 x to the 4 from 0 to 5. Thank goodness one of the limits is 0. So you got 125 times 5. 625 over 3 minus 625 over 4. Make the least common denominator 12. So you got 625 times 4 minus 625 times 3. Factor out a 625 and you got 4 minus 3, which is 1. See how it's good not to multiply it out? All over 12. So that's the top. So the x-coordinate of the centroid is going to be 625 over 12 divided by 125/6. Now that's like multiplying by the reciprocal. And let the canceling begin. 6 goes into 12 2 times. 125 goes into 625 5 times. You get 5 halves.
This work.
Mhm.
On the test, if it doesn't cancel in the last step, should we assume that it's wrong?
No,
No.
no. No, sometimes they don't cancel.
Or are you gonna make it like pretty?
Oh, no, it's hard to make these problems come out like super nice.
Okay.
Okay, now I need to do the y one. So the y coordinate of the centroid would be the double integral of y dy dx, and again, so the limits are not going to change. X to 6x minus x squared, 0 to 5, all over the area. Let's not reinvent the wheel. We know it's 125/6. Okay, then what the heck, let's just do it. So what's the integral of y with respect to y? 1/2 y squared from, we're going to do 6x minus x squared. Factor out the constant, so you go 1/2, so you're going to have 6x minus x squared minus x squared dx from 0 to 5. This is, we got to actually multiply this out. Let's throw the constant on the outside. So if we multiply that out, what are we going to get? This is 36x squared minus 12x cubed minus x to the 4th minus x squared. So that's 35x squared minus 12x cubed minus x to the 4th dx. So 1/2 times, what's the antiderivative of this? 35 over 3x cubed minus 3x to the 4 minus 1/5 x to the 5th from 0 to 5. These numbers are going to be gargantuan.
Yeah.
No, but we can factor. So what do we got? 1/2, 35/3 times 5 cubed minus 3 times 5 to the 4th minus 1/5 5 to the 5th minus 0, right? What can be factored out?
5 to the 4.
Oh, 5, no, 5, yeah, 5 to the 4 over 15, correct? Yes. If I factor out a 5 to the 4th over 15, what do you get? Who's got the first term? Park. Factor out a 5 to the 4th
Okay.
over 15.
Wait, why are you?
Because there's going to be a least common denominator. Remember, when there's fractions, you should always factor out the least common denominator, right? So then-
5, 3, 7 over 5.
No, 7 times 5.
Why? Cause isn't that 5 to the third?
Yeah, but that's because 35 is 7 times 5, that's why I see, so that's actually
Oh,
5
yeah,
to
yeah,
the,
yeah.
that's actually 5 to the 4.
Okay. Oh yeah.
This is so we don't have to multiply out large numbers.
Yeah, then 35.
Okay, 35 minus, huh?
45.
Yes.
5 to the 4. 3 times 5, 15, huh?
So that's 45. Oh.
45.
Oh, because there's no denominator. Ho, 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 ho.
Oh.
Yeah, you're right, it's 45. Hey, this thing is coming out negative. Something's wrong. Are you sure it's 45? Yeah, it is.
Maybe you forgot to give.
Oh, look how stupid I am. That's supposed to be a plus sign.
Ah, I thought that was where I made a mistake, but
It's a plus sign. Okay, and then finally, what happens if I factor out a 5 to the 4th over 15?
50.
So you get 3, you get 50. This is a positive. Now the answer comes out positive. So this is negative 10 plus 15. What is all of this? 5. 5 goes into that 3 times. So we got 5 to the 4th, which is 625 over 6. Woo! That's the numerator then. 625 over 6 divided by this, but that's like multiplying by the reciprocal. Baga baga 5. You have 5. Is that the answer?
Yes.
So the centroid is, what was the x-coordinate?
5 halves.
5 halves. So the centroid is 5 halves, comma 5. So you can see, that's only a 2-dimensional one. Wait till you see the 3-dimensional one on the test. It'll be like a paraboloid, maybe a hemisphere or something. Okay, now you want me to set up the number 2 you said, yeah?
Can you solve number 2?
oh wait,
Actually.
the part I didn't get was the x part on number 2, but now I get how to do the x.
Okay, well,
It's a long time.
let's just do it for funsies. Well, I'll set up the integral, and if you have questions on how to do the integral. Okay, so the x-coordinate, okay, well, first of all, what is the region in number 2? A, B, and C are positive. Here, let's draw. So we have a tetrahedron in the first octet, like this, right? The x-intercept is A, the y-intercept is B, and the z-intercept is C. Find the centroid of this tetrahedron. You can probably guess what it's going to be before we even start.
Wow.
A over B, A over 3, B over 3, C over 3. Just as a gut feeling.
Wait, what?
A over 2, B over 2, no. What the heck, let's just compute it. So we have a triple integral. Now if we're going to find the x-coordinate of the centroid, it's going to be x. Now in this case, I would go dz first, then dy, then dx. That's what I would do.
Oh, I know what I did wrong.
Okay, so z goes from the bottom, what is the bottom on the xy plane?
0.
0. To whatever the equation of this plane is. What's the equation of the plane if the x-intercept is, the intercepts are a, b, and c? Wouldn't it be x over a plus y over b plus z over c equal 1?
Yeah.
So solving for z, z equals c times 1 minus x over a minus y over b, correct?
Oh,
So that's what this upper limit is going to be. Okay. Now, on the xy plane, like this, if we're just looking straight down on the xy plane, you're going to see this, right? Which is that's A and B. So y is going to go from y here to y there, right? So obviously on the bottom, that's y equals 0. What is this? That's an equation of a line, right? Well, what's the equation of this line in the xy plane? Isn't it x over a plus y over b equal 1?
Yeah.
Right? Because if you think about it, if you said z equal to 0, right? So if you solve for y equals b times 1 minus x over a. So that's what this upper limit is, b 1 minus x over a. And then finally, if you integrate with respect to x, you're going from here to here. So that's 0 to a. The last one always has to be the constant. Yeah.
Why did that for the triple integral to solve for x, you use x, but then for the double integral, like the 2D shape, you use y dy to solve for x.
Say it again.
So you know the question you did before,
Mm-hmm.
you to find the x coordinate of the centroid, you use double integral y dy.
No, it was X.
Really? I think
You
you
did both.
I did both of them.
Oh.
Look at the
No,
formula.
no. When you were solving for x, I think you used y.
No, I didn't.
You did?
Oh, are you talking about, yeah, the other day?
No, today, just now.
No,
You
you
did
did
both.
both.
You did x.
I did both. We did both of them.
Oh.
So look here. It's easy to remember. If that's X,
Yeah.
that's X.
Okay.
Yeah.
Yeah, I was just confused.
And
That's
then how do you do the find the volume? Well, we know the volume of the tetrahedron. We don't need to reinvent the wheel, right?
ABC over 6.
Okay, ABC over 6. Let's not reinvent the wheel. Okay, do you want me to do this integral? And then the only difference with the other two is that if you want to find the y coordinate of the centroid, that's going to be a y, and then the z coordinate would be a z. That's the only difference. You want me to do this one then? No need.
Yeah. Wait, no. Wait, I don't know.
What do you mean you don't know?
I have to look on that.
I think I'll just do it.
Yeah.
Yeah, no.
'Cause I couldn't.
Okay. And then what about number 3? We got a polar curve here. Do we need?
I could.
We don't like polar
You
curves.
need to know how to start.
I know you.
What?
Started.
The centroid of the regions. First, you draw the picture, Jason. Okay, what if I were to draw this? What is it going to be? It rhymes with Mardioid.
Cardio.
It's a cardioid. So plot the quadrantal angles. There you go, Cho's checking out again. Just like I told Fleischer. The highest average is not necessarily the top student, you know.
Which
Like
Fleischer?
Fleischer took this class.
No,
Which Fleischer?
Sam Fleischer. And that's exactly what happened. So if you plug in 0, you get 2a, correct?
Yeah.
Yeah.
Okay, what happens when you plug in pi over 2? You get a. Pi, 0, 3 pi over 2, a. So, here's Johnny. So, since we have okay, we need to find the x coordinate and the y coordinate of the centroid, but what is the y coordinate of the centroid?
Zero.
0.
0.
0, because of symmetry, right?
Yeah.
It's gotta lie on this line somewhere, right? If you like, you're gonna balance it.
Yes.
So the y coordinate gotta, so it's the x coordinate. So double integral of x. Now the thing is, we're not gonna do this. There's no way we're gonna do this in the rectangular coordinate system, right? So you have x here, but instead of using dx dy or dy dx, what is the thing for the polar coordinate? R dr d theta. And then of course you have to change the x to, what is x equal
X
to?
sine theta. R cosine.
R cosine theta. And then, so, if you integrate with respect to r first, r will go from 0 here. You know what you do with the polar coordinate system? Try to draw that sector of infinitesimal width there. So r will go from 0 to whatever the equation of the curve is. So 0 to a 1 plus cosine theta. And then theta gotta go from, well, you gotta wait till the ringing stops.
You do 0 to pi.
It stopped though.
0 to 2 pi. Or you can go 0 to pi and times it by 2 because you have symmetry now. But what's that? Just go 0 to 2 pi. Okay, there you go. There's your integral. And then of course, then you gotta, so the x coordinate of the centroid is this divided by the whole volume. So to figure out the whole volume, it's just gonna be r dr d theta with the same limits. It's gonna be 0 to a 1 plus cos theta, and then 0 to 2 pi. The only difference between the numerator and the denominator is this one has the x, right? And then the y one has the y. And the z one has the z. Yeah. Can you guys do these integrals?
Yes.
Okay, good.
I was confused, so I was trying to figure out the rectangular value of x for the left side. I couldn't figure out like the.
Yeah, that would be too difficult. That's why we have these other coordinate systems. Okay, there was only 3 problems.
Another 4.
Joe, are you covering your mouth when you're coughing?
Oh,
Do you need a cough drop?
Yes, please.
How many cough drops have I given you so far in your lifetime?
Can I have one too?
3.
Here we go.
You gave me a lot though. I asked for it.
So who wants?
I don't want to cough.
What happens to sit on that loan up there?
Well, that one's gone. You
Is it
guys.
lemon honey?
This is honey lemon, sugar free. Okay, let's go so we can play a game, man.
Wait, can you tell us what the game is?
No, because then you might study.
What?
Is it one of those list things?
Okay, now we're gonna compute volumes in the cylindrical coordinate system, and then when is the next time I see you?
Monday.
No, Monday. No, Monday is
Tuesday.
Tuesday. We'll do volumes in the
In a week.
spherical coordinate system. Now, do we need to review what the cylindrical coordinate system is?
No.
Even though we did it last time.
R theta z.
Okay, very good. In the cylindrical, so rectangular coordinate system, x, y, z. Cylindrical coordinate system, r theta z. In the spherical coordinate system, rho theta phi.
Yeah.
Okay, and then remember to convert from one to the other, remember draw the rectangular box. From PCH, draw the box. Okay, let's do one. What the heck, you guys don't just want to do number 1 together?
Yes. Let's do number.
That's just the paraboloid again, yeah? Didn't we do the paraboloid? Yeah, we did. Let's do it again. So, let's do number 1. That means you only have 2 problems for homework. Happy Thanksgiving.
Thank you. We're grateful.
Find the volume of a solid which is bounded above by the paraboloid z equals 1 minus x squared plus y squared. See, the hint is anytime you see a quantity x squared plus y squared, that's telling you, yeah, integrate me in the cylindrical coordinate system, right there. And then if you see x squared plus y squared plus z squared, then you do it in the spherical coordinate system. And the xy plane. So basically, it's just, the cap of the paraboloid right there. So we're going to do a triple integral. Whoop, whoop, whoop. Now, in the rectangular coordinate system, see, here's the difference. dx, dy, dz, right? That's like the volume of a rectangle of infinitesimal width. But remember in the polar coordinate system, like, when you make the sector like this, remember we did that? What is the area of this thing? R dr d theta. But now there's going to be a height to that. I'm trying to draw a picture. Wait.
Is it r dr theta or r dr d theta?
Yeah, r dr d theta. So you have it like this, but then now there's like there's a height to it which is dz. So then you get dz. It's like this. It's not really a rectangle. It's not a rectangle. But a rectangular thingy.
Okay.
Okay, so it's r dr d theta. Oh gosh. Times the height, which is dz, infinitesimally small. So here we go. So that's what you put here. R dr. So now you got to determine which one you're gonna integrate with respect to first. So that's why you don't even write it. So what do you want to integrate with respect to first? I would say z, right? So dz, because z goes from the bottom to the top. The z on the bottom to the z on the top. What's the z on the bottom? 0. And what's the z on the top? 1 minus x squared plus y squared. But what is x squared plus y squared? R squared. So that's actually the upper limit. Then you integrate. So again, if you smash it down onto the xy plane and you look from above, you're just going to see a circle of radius 1, right? Okay, so if I integrate with respect to r first, what? R goes from here to Yeah, so 0 to 1, because it stays constant, right? All the way throughout. R is always 1 no matter what. And then finally theta goes last, 0 to 2 pi. Because it goes from here.
But we could have done theta first and then r.
Yeah, so since both of these are constants, it doesn't matter which one you did first. Okay, so now all that matters is, now you compute. Did we do the centroid of this? You know what, after this we're gonna do the centroid for funsies. Okay, so what is the integral of r with respect to z? rz from 0 to 1 minus r squared, factor out the constant, so you just have 1 minus r squared minus 0, which is r minus r cubed.
Yes.
Then we're going to integrate that with respect to r from 0 to 1. So what would that be?
1/2 r squared minus
1/2 r squared minus 1/4 r to the 4th from 0 to 1. And that's just 1/2 minus 1/4 minus 0. That's just 1/4. Then we're going to integrate that with respect to theta from 0 to 2 pi, and you guys know already that basically just multiply it by 2 pi, right?
Yeah.
Okay, never mind, let's just do it. 1/4 theta from 0 to 2 pi, factor out the constant, so that's 1/4 times 2 pi minus 0, so that's just pi over 2. So the volume of this paraboloid is pi over 2.
Not that bad.
Okay, now, on my test, you're gonna compute centroids, because, see, if I ask you to compute a centroid, then you have to do both, right? You gotta find the volume, right, because that's the denominator, and then you also have to do another integral, so that's like getting 2 meals in one. So, can you see from symmetry that the x and the y coordinates of the centroid are both gonna be 0?
It is. Oh yeah, it is.
Yeah.
So the only thing you have to figure out is what is the z coordinate of the centroid. So we know this is the denominator. What's the numerator? We need room here.
Triple integral.
Okay, so triple integral of z, right?
Yeah.
And then everything else is the same.
Easy.
R dz dr d theta from 0 to 1 minus r squared, then 0 to 1, and then 0 to 2 pi. This will be the numerator for the z coordinate of the centroid. So, what is the integral of zr with respect to z?
Half z
1/2 z squared r. Correct? From 0 to 1 minus r squared. I'm curious what the answer is, aren't you?
Yes.
R over 2, 1 minus r quantity squared minus 0. So r over 2 times 1 minus 2r plus, no, 2r squared plus r to the 4th. So that's 1/2 r minus 2r cubed plus r to the 5th. Tell me when I make a mistake now. Okay, now we gotta integrate that with respect to r from 0 to 1. Let's throw the 1/2 on the outside. So you got 1/2 times 1/2 r squared minus 1/2 r to the 4th plus 1/6 r to the 6th. 0 to 1. 1/2. So what do we got? 1/2 minus 1/2 plus 1/6. Hey, it's kind of good. The 1/2s cancel out. What is 1/2 times 1/6? So you get 1/12. Now you got to integrate that with respect to theta from 0 to 2 pi, but that's basically just multiplying it by 2 pi. So what's 2 pi over 12? Pi over 6. So the z coordinate of the centroid is pi over 6 divided by this. So you multiply it by the reciprocal, booga booga, you get 1/3. So if this is 1 up here, then 1/3 would be, right? That makes sense, yeah? Because it's got to be closer to the bottom because there's more mass on the bottom, yeah, of the thing. So the coordinate of the centroid would be 0, 0, 1/3. There you go. Okay. That was fun. So Tuesday we got spherical coordinate system. I think is that the last? Is that the last section?
No, there's surface area.
Oh, surface area. Oh, that's one of my favorites.
Wait, is Surface chapter 20? Or is it
No, it's in the last homework.
It's MVC 7. Wait.
Surface area.
Why are two chapters?
Okay, we don't have to play games. What time does this class end? It started at 40, it ends at 50 then. We got 40 minutes.
Let's play a game.
Yeah, that's why I made a game this morning. Wait, before we start the game, we're gonna start uploading this video, because I got a video period 8.